This is the question right here. Again, you don't do conics, but you can graph. Hopefully you can graph that circle. Incidentally, if you're not sure why the equation of a circle is that, because again, I don't know what the decision was to take conics out of Math 12 in this province, but if you have a circle, I will try to draw it so that it's centered right there somewhere. Is that more or less? That is not even close, because I always forget that the screen is actually different up there than my screen here. So we're going to try again. That's not. It's close enough? Oh. Okay, that's good enough. If this is a circle here, this is 3. Okay. Where the equation of the circle comes from is this. If that point is x, y, it's just if you use Pythagoras here, this is the radius. This is x, this is y. The equation of a circle that's in the center is x squared plus y squared equals r squared. It's just Pythagoras, right? If you have not looked at that before. So if you have a circle that's equation is x squared plus y squared equals 9, the radius is 3. The radius is the square root of that number. Okay? If you wanted it centered somewhere else, you would just transform this, right? Like if you wanted this whole thing to be 2 to the left and 3 up, then you would make this x plus 2 squared, right? And y minus 3 to shift it 2 to the left and 3 up, right? But that's not what we're doing here, so now I got to do a whole bunch of undos. How many undos does this take? Too many? I guess. Sadly, that's probably one of the most interesting things, is those kind of things.
Not for Mr. Burnwell. He'll be watching this.
Anyways, if you have your function here, if you're going to use this, you need to rearrange this as a function of y, right? So you can change it to that. Since it has a top half and a bottom half, you have to express it as y equals plus or minus square root of 9 minus x squared. On the calculator, if you wanted to graph it, because you can only graph functions, you'd have to graph y1 is positive square root of 9 minus x squared, and y2 is negative. Okay, if you were putting this on the calculator, negative y1, the minus square root of that, square root of 9 minus x squared. That's how you'd have to put it in the calculator. You'd have to do the top half, and then the... But if you want to set up the volume of this thing, remember that if you're trying to draw what these shapes look like, in 2 dimensions it's hard to draw what they look like, but you have squares rising up out of the page that look like that. The cross section is that, right? It's supposed to be vertically out of the page. So it probably helps to draw the area somewhere else, right? To draw a square somewhere else and say, these are supposed to be squares. So there's more or less a square. Think about what this has. This distance right here, we can get rid of this because we don't need that anymore. This thing is this right here. So if that is, if this is y and this is y, this is 2y, right? The side of the square is 2 times y, and it's a square, so that's 2 times y. So the area is 4y squared. So then the volume has to be, I didn't leave myself a lot of space here. The volume has to be the integral from here all the way over to here of those things. You're finding the volume of each one, and the volume of each one is the area, 4y squared. Maybe I'll start by saying area. The area is a function of x times dx. That's the thickness, right? This is the area, and this is the thickness of each slice. This model that I showed you before, the thickness of each piece of cardboard is dx, basically. Well, it's not dx unless we made them infinitely thin. If they had used the thin kind of cereal box cardboard, they could have made it more smooth looking. Basically, you're doing this by squishing them down to infinitely thin, right? Paper or whatever, really thin paper. Okay? That would be pretty, it'd be pretty hard to make it work so that it's nice with all those layers, but it'd be pretty cool if you could do it. And then you need the boundaries here, -3 to 3. So it's integral of 4y squared dx, but we don't want to leave it as, you can't use 4y squared. You need this to be a function of x. So instead, of course, you need 4 times square root of 9 minus x squared, right? Dx. Can't you just? Yes, you can. I think what he's saying, I'm predicting, is that can't we just deal with this? Just square root squared, simplify it? Absolutely. I would simplify it before you do anything, whether it's on the calculator or not. This is incidentally still part A, by the way. I just I don't have enough room up here. I have to write big up here. So all those times that I say, oh, don't you have a lasso tool? See, you have enough room, and I don't know. 11 minutes, you guys. Oh.
Keegan, were you just waiting for that?
It's all. I might as well keep going, but don't start to say, oh, 22 minutes now, okay? Because at 10 again, I have to. 16 would be good. Actually, no, we'll see. At the end of this, we'll stop it. Anyways, if you simplify it a bit here, if you're doing it analytically, you could change this to get the symmetry of the thing, but we have 9 minus x squared dx because you get rid of the square roots. If the 4 put out here, if you were going to do this analytically, you might want to change this to a 0 and then double it, right? Why would you triple it? It's what I'm saying is if double it to say, the thing is symmetric, just take half the thing, right? Times it by 2. So start here and go that way and times it by 2, but it doesn't matter. If you're using the calculator, whatever you like. Once you get to that point, you can put the answer, unless, it probably, if you want, you can put this and say I did it analytically, but certainly on the AP exam, they make it clear they don't want you to put F and int blah blah blah. They don't want the calculator syntax. They want the mathematical notation. And
What about arc? We'd be allowed to calculate that.
Oh, yeah, well, since it's the same, is that what you're saying? So they won't know. So as long as you put the mathematical notation, then you can say that's approximately this much, or or exact value, whichever way. Okay. So what is this? Somebody done that?
144.
Well, there's no pi involved now, right? So maybe one thing to realize here as you work through this is, why was there no pi involved in this one? Yeah, because it doesn't involve a circle. It doesn't revolve. There's no circle involved. So if on your unit test I tell you something about squares, I'm always surprised at how many tests I mark where somebody has a pi involved here because they think, oh, wait a sec, what was that? There's volume, it involves pi somehow. Don't have a pi involved here if there's no circle involved, because what you're telling me is I have no clue what I'm doing. I'm just trying something here to get it to work. Okay, so at least think about it that much that we have, this is not a circle, this is not a circle. If it's a circle, if I put a semicircle, yeah, pi is going to be involved. Can you make what? You could find the volume of a sphere for this if you made the cross sections a circle. Absolutely right. This would be if you put it on here. Let's see. So we want to put in here, if we want to do the volume of a sphere, it's a very good question. You could generate the formula for the volume of a sphere that you've done before. That is a good question. I like that. So if we had, square root of 9 minus x squared. If you wanted the volume of a sphere, like the formula, you'd have to make the 9 a variable, r squared, like a constant, but a variable. So that's the first function, and the second function is, what's the other function? Negative, right? I don't know if it lets me do negative f of x, so let's just put it in this way. Thinking we need to zoom out a bit here. Let's pause. Now that people missed all that excitement. Now why am I doing this as a separate, why I should have stopped it? This would have been a good place to stop it.